Hello, Algebra 1 students. Mr. Ford here from the Mr. Ford home studio. Kind of forgot on my way out the door today that I know while I'm recording this, this is Mr. Ford from the future. Tomorrow, which is when you're currently watching this, I'm going to be at a doctor's appointment in the morning. So, my first hour, friends, I'm not going to be in class today. I'll be heading to the building sometime between 9 and 9:30. So, that means that first hour, after you finished your test, the instructions are for you to watch this video and do these notes along with me. You can find this right at the front of the room. This is 3.1.1, and the title of this lesson is How Can I Rewrite It? And the goal here is to simplify rational expressions. I'll give you a second to pause right now. If you don't have this sheet in front of you, you should grab it because I'm going to walk you through a few things, and I'm going to show you kind of what I expect you to get out of this exercise before you have some time to work on it with some shoulder partners or with a table team. You will be getting new groups, just not today because it's the day before Christmas break. Okay, so the goal today is to simplify expressions with exponents. So let's talk about this for a minute. First of all, a rational expression. Let's zoom in on that for a moment here. A rational expression. The word rational in mathematics refers to the word ratio, which really means a fraction. A ratio is something that can be expressed as A over B. So any expression that's got a fraction bar in it and has some stuff on the top divided by some other stuff on the bottom of that fraction, this is what's called a rational expression. So I left some room here at the top for you to have that note down, that a rational expression is just defined as something divided by something else. If you really want to get real stinky, we usually write them in this format, f of x divided by g of x. Two functions that are being divided. Not necessary for you today, but hey, you're in high school math. You might as well get used to it. That's where it's going. So I keep pointing at this monitor, but really I want to point over here at that work. That's interesting. Exponents are a whole other thing too. Today we're really talking about exponents. So an exponent, well, usually you say b to the nth power. And in this case, the b would be what we call the base, and n is what is referred to as the exponent. And, we often always run into these problems when you learn about exponents in the first place, not to be confused with multiplication. An exponent is repeated multiplication. So if I say, for example, b to the fourth power, this means I'm going to take that b number, I'm going to multiply it by itself 4 times, like that. That's b to the fourth power. One thing we're going to see along the way today is how to handle what's going to happen when this number is negative, but we'll get to that in a moment. So let's just keep that in mind. So here we go. If you didn't know that, it's explained for you right again in 3-1. So here it is. An exponent is shorthand for repeated multiplication. For example, n to the fourth is n times n times n times n. And an exponential expression like b to the a, we call the bottom number the base, and the little tiny number is called the exponent. So what we're going to do right now in 3-1, if I was there in person, we'd do this together, but I'm not. But you can do it right now. We're just going to expand these expressions out by building on your understanding of what an exponent is right now. For example, y to the 7th power is y times y times y times y times y times y times y. All together, you got to have 7 y's, and they're all being multiplied together. Obviously, exponential expressions tend to be very, very large because multiplying the same number 7 times in a row is going to give you a huge number. So we used to that. Now look at b. Here's the thing too. The base in this case is actually made up of 2 numbers. It's 2m. 2 times m. And it's being multiplied by itself 3 times. So if we follow the instructions set forth in the definition of an exponent, it looks like this. First of all, I'm going to draw a little line there to separate the work. 5 is not affected by that third power. 5 is not being raised to the third power. 2 times m is being raised to the third power, but not 5. So 5 is just going to vibe right there by itself. So we're going to have a 2m. I like to put it in its own little parentheses like that. Times another 2m. Times another 2m. just like that. Usually, the most common mistake made here is that people forget to do the 2. They will leave 2 alone. But the third power is applying to that whole yellow parentheses. So that's the thing we're going to multiply by itself 3 times. Over here, this is interesting. We have x to the third to the second power. So what we're going to do is we're going to multiply x to the third times x to the third. That's what it means to square something, or take it to the second power. You multiply it by itself. Now, of course, we can expand this out even further. And x to the third is x times x times x times x times x times x. And what I'm hoping you're seeing here is that this is equal to x to the 6th power, but more about that in just a moment. And one more thing finally. Again, here we have 2 different bases. We've got 4 and we've got x and we've got y. X is being raised to the 5th power, y is being raised to the 2nd power. So you got 4 times x times x times x times x times x times y times y. Notice that the 5th power only applies to x, so there's 5 of those. And the 2nd power only applies to y, so there's only 2 of those. You know, my advice on this stuff is the same as my advice to everything in Algebra 1. Take your time, especially when you're new at it. Take your time with it. There's a lot of stuff that can get confusing if you're going too fast. So slow down. Only apply the exponents to the things that are actually being raised to the power. You'll see the patterns pop up pretty quick. Now, speaking of patterns, here's where I'm going to do a few of these problems with you, but then I'm actually going to stop the video and actually have you finish the rest of this kind of on your own in class. But my intent is for this video to be about 15 minutes long, so you could reasonably tomorrow finish the test, do this, and then do the homework. So 3-2, Mrs. Wang has just explained to her class how to simplify expressions or exponents by using the number 1. Very key concept. You might remember this from your middle school classes. She wrote the following on the board, and so let's take a look at what she's got here. Our job here is to explain each step in her work, so let's try to do this. So the first thing it looks like she did is I noticed that she kept x kind of by itself. X over 1 is right there. A big conversation with rational expressions. This is, by the way, in case you're wondering, this is a rational expression. Because it's got some stuff divided by some other stuff. It's got something on top, something on bottom. A good thing to keep track of when you're doing these kind of problems is what's on team top, what's on team bottom. In this case, it looks like the x is on the team top, and you have y to the 8th on team top, but team bottom is y to the 2nd power. That'll come up more and more as we dig deeper into this stuff. So, okay, looks like x is just kind of hanging out by itself, x over 1. There is an over 1 there because x divided by 1 is part of this. It looks like she split up y to the 8th power into y squared times y to the 6th. And I think that is completely okay. Y to the 8th power got split up into y to the 2nd power times y to the 6th power. That's okay because that's either way. This is 8 y's and this is 2 y's plus 6 more y's. So either way, it's going to work out to be the same thing. I also noticed that she arranged the y squared over y squared, and I think you remember there's a lesson in the middle school math curriculum where you do this thing where you draw a big number 1 like this, and they call it the big 1. Does that look like a 1? That's backwards. Hang on, I think it goes this way. Yeah, kind of like that. Because y squared divided by y squared has the same thing on the top and the bottom, and therefore it divides out to be 1, and that's what happened there. In this second step, I think it's exactly what happened, is that y squared over y squared equals 1, so she substituted in the 1 for the y squared over y squared. I like to use colors for things whenever possible. Nothing else changed. X over 1 is still x over 1. And y to the 6th over 1 is still y to the 6th over 1. It looks like then everything kind of got combined together. Everything just kind of got multiplied all the way through. I mean, when you multiply or divide by 1, nothing happens. 1 is kind of the magic number when it comes to multiplication. So now that we have everything kind of over 1 or multiplied by 1, it looks like she went ahead and combined everything together. I'll say combined everything back together. And then finally, yeah, again, so if you have something divided by 1, that's just the same as just that thing. So anything divided by 1 is equal to itself, kind of like that. So that's all that happened there at the end. So it looks like she actually kind of blew it up to begin with, separated it out into its parts, divided the y squared over y squared to get 1, and then was left with x times y to the 6th. Now, hopefully, at this stage in the game, if you're looking at this problem, I'm hoping right now that you have seen a pattern, a way that you could have gotten through this a little faster. And what I'm hoping that you saw was that x kind of happened out there, but we had y to the 8th over y to the 2nd. And what happened is that, well, there are 8 y's, 2, 3, 4, 5, 6, 7, 8 on top, and 2 y's on bottom. And the 2 on bottom canceled out with 2 of the ones on the top, leaving the 6 left over. So there's times x there too. Now, a shortcut that I hope you're noticing is that you can take 8 and subtract 2 and get 6, because that's exactly what happened in this problem. 8 minus 2 equals 6. But we'll get to that in just a moment. I like to preview little shortcuts with you. Now, in question B, we are asked to simplify each of the expressions below using what you know about exponents and the number 1. Start by expanding the exponents and simplify your results. We're going to run through these 8 examples as fast as we can, and then I'm going to turn you loose on the rest of this, and we'll talk about it as a class maybe Wednesday, or if I don't see you, because you're in my 6th hour, I will talk to you after break. But let's just do these. So, question number 1. I'm going to zoom way in on these as we work through them. What I notice here is that, well, you can cancel this x out with that x, one of those. And what you'll be left with is x squared. If you wanted to expand it out the way that they did in the previous problem, you might notice that you have kind of a maybe x times x over 1 times x over x, and the x over x can become the number 1, and it can cancel out, leaving just to the x squared. But that's kind of what I want you to see. Next question. Now, we could expand this out again. We could do this as x times x times x times x times x over x times x. And I would hope that you would see that these two divide with those two to make 1, and then multiplying by 1 doesn't do anything. And so what you're left with is x to the 3rd. You know, like that. Hopefully you're seeing that 5 minus 2 is 3 also, but that's not required yet. Now here we got an interesting one. This is x squared times x to the 3rd. Now if you expand this all the way out, you got x times x, that's x squared, times x to the 3rd, which is x times x times x. That's x to the 3rd power. Now, all those put together is x to the 5th power, because there's 5 x's there. Hopefully you're starting to see a pattern that 2 plus 3 equals 5. That would be a good thing to see at this point. Over here, you might make a prediction right now, n to the 8th power, because 3 plus 5 is 8. And you'd be 100% correct. N times n times n is n to the 3rd, times n times n times n times n times n, which is n to the 5th. And that is n to the 8th power when you're all done. And hopefully you're seeing that 3 plus 5 equals 8 thing that's going on there. Question 5 is going to get a little tricky here. I think it's a good idea in this question to separate the number parts out first. Let's keep 16 over 8 separate from the rest of this problem. We have 3 w's on top and 2 w's down below. Now the numbers kind of have their own little game hanging out here. I would not combine them together with any of the exponents. They don't follow the same rules because they're just numbers. The w to the 3rd and w squared, those can do something different. 16 divided by 8, of course, is just 2. And I hope you see that these two cancel out with those two, and of course 3 minus 2 is 1. W to the 1st power, which we would never write. We don't write w to the 1st power, we just write w. It's one of those things. So there you go. This one is an interesting one. It's checking to see if you recognize that that is m to the 1st power. This would be, if you were to expand it out, m times m times m times m times m times m. That's m to the 6th. Times one more m. And I hope you're seeing why we're actually going to add those all together. That's going to be m to the 7th power. when you're done. And this is still testing to see, do you recognize the pattern of 6 plus 1 equals 7? Well, first you got to recognize the fact there's a 1 there. It's not so obvious. Now here we got x to the 4th times x to the 5th times x to the 3rd. Hopefully at this stage, you're going to go ahead and write x to the 12th power, which would be correct. Because you got 4 x's, I'm just going to put them in kind of a group right there, times 5 more x's, times 3 more x's. And that is going to be 12 x's altogether. And I would make sure to make a note of that. 4 plus 5 plus 3 equals 12. Here's kind of where this is going. You'll see these kind of questions on algebra homework and quizzes from now on as questions like this. First things first, let's separate out the numbers. Again, the numbers are usually a thing you want to pull off to the side and just let them do their own thing first. 6 over 2. X to the 3rd, let's put that over 1 since x to the 3rd is on team top. So we'll keep it there. And then we also have y over y. So what's going to happen here? 6 divided by 2 is the number 3. X to the 3rd is just x to the 3rd. And these guys divide out to be 1 because that's a big 1 there. And that is just 3x squared, or 3x to the 3rd would be the correct answer there. Kind of a bonus challenge question. Do you really see the patterns going on here? Let's go ahead and do it anyway because it's not even that tough of a question. First of all, let's leave the 5 over 10 off to the side. And let's think about x to the 50th power divided by x to the 15th power. I think a lot of you guys know 5 divided by 10 is 1/2, so we'll keep that kind of off to the side for a moment. But at this stage, you do not want to draw 50x's and 15x's and cross them off. But hopefully you're recognizing the pattern that 50 minus 15 is going to be what's left over. 15 x's on the bottom will cancel out 15 of the x's on top, leaving 35 behind. This is 1/2 times x to the 35th power, or x to the 35th over 2. These are the same answer. They look the same. They make the same thing happen. Now, with this video as your starting springboard, I'd like you to do as many of these questions as you possibly can. You're looking for shortcuts. You're looking for patterns. You're looking for things that will happen. I'll provide you with an answer guide probably right now as you are working through this problem. Working through that, I'll really quickly here at the end of this video, I'm just going to throw the answers down and think about them really quick. Your job for the rest of class today is to finish all of 3-3, to finish 3-4, be ready to discuss 3-5, and on the back side here, you do have a homework assignment, 3-6 through 3-11, which will, let's see, you guys will see me on Wednesday if you're in 1st and 3rd hour, but 6th hour will not. This will probably officially be due shortly after we return from break. Probably not right away because I'm not a madman. I kind of understand the vibe of Christmas break. So anyway, with that having been said, here is I'll just throw an answer key down for you. Y to the 7th, W to the 3rd, X to the 8th, X to the 22nd power. This will be 13p squared Q to the 3rd. This is going to be x to the 6th power over y to the 3rd. This will be 10h to the 25th. This will be 5m to the 22nd. This will be 81k to the 80th. This will be 8g to the negative 7th, or 8 over g to the 7th. This will be, let me think about this one for a minute. This is going to be m to the 12th divided by m to the 40th, which is m to the negative 28th power, also known as 1 over m to the 28th, but we'll get there in a minute. This last one will be w to the 7th times p. That's all there's to say about that one. There's your answer guide. Now, of course, you got to show me some work on how you got there. I'm doing it all in my head because I'm a pro, but you're not a pro yet. Maybe you are. Who knows? Hey, I will see you guys. If you're in my 1st hour and you're watching this video, I'll see you on Wednesday. Otherwise, have a great day and do this homework. Do the rest of these problems. Make up some, in 3-4, you got to make up some problems that have an answer of x to the 12th. 3-5, there's going to be some students that are arguing about what's right and what's wrong. And then you got a bunch of homework questions to do, which I'm probably going to record an answer guide for during the day tomorrow. We'll see. All right. See ya.